In this video, we're going to be solving some equations for x, but we're going to begin by talking about what an extraneous solution is. So an extraneous solution is really an answer you get that does not work when you plug it back in. So an answer that doesn't work. So we're going to go ahead and we're going to solve these equations here, these examples, and see if we might run across an extraneous solution. So in our first example, we have 4x over 9 minus 1/3 equals x plus 5 over 3. So I'm going to notice that all of my denominators are multiples of 3. And so just to make this a little bit easier, I'm just going to multiply everything by 3. Just everything by 3 so that I can get rid of some stuff. I don't know if 3 is going to be enough. Because we still have a fraction here. So what if instead of multiplying by 3, we multiplied by 9? And this is just one way to try this problem. There are actually lots of different ways to solve it. So here I'm going to have 36x over 9 minus 9 over 3 equals 9x plus 45 over 3. And then I can simply simplify my fractions, and that's going to give me a 4x minus 3 equals 9x plus 15. And then from here, I'm going to go ahead and subtract 4x from both sides. That's going to give me a negative 3 equals 5x plus 15. Then I will subtract 15 from both sides. And that's going to give me a fraction. So we're going to divide both sides by 5 and get x equals negative 18 over 5. And then we're going to check that by plugging it back in to see if it will work. So we're going to check our answers, and kind of out of room, so let's just check our answer right up here. That's just fine. So 4 times our x over 9 minus 1/3 equals x plus 5/3. So we're going to plug in this negative 18 over 5. And we want to know, do these two sides match? So we're going to plug in this side into the calculator, and we're going to plug in this side into the calculator, and we're going to see what we get. So when we plug those into the calculator, we get negative 29 over 15 on our left side, and a negative 29 over 15 on the right side. And when we compare them, we see that they are the same, meaning that x equals negative 18 over 5 is a solution, and it works. Let's take a look at B. This one's going to be a little bit tougher with how we work it out. We're not just going to multiply by 9 everywhere. But we will need to get common denominators. So I'm going to begin by factoring our denominator right here, because our other denominators are already in their lowest terms. So here we have an x plus 2 and an x minus 2. So notice that the x minus 2 is in our first fraction, and that the x plus 2 is in our second fraction. So our third fraction has both, but the other ones are lacking. So we're going to get some common denominators. So we're going to have to multiply. Let's give ourselves a little bit more room here. Just scoot that over. Okay, so we're going to take our 1 over x minus 2 and our 3 over x plus 2, because those are what are missing. So our 1 over x plus 2 is missing the x plus 2, or 1 over x minus 2 rather, sorry. And our 3 over x plus 2 is missing our x minus 2. Let's write that one in, because yellow won't really show up. So x minus 2. Okay, and so that's going to give us an x plus 2 over our x plus 2x minus 2. And that's going to give us a 3x minus 6 over our x plus 2, x minus 2. All right, so again, this was equation 1, or fraction 1, fraction 2, fraction 3. So fractions 1 and 2 needed to be fixed. So let's go ahead and let's put those back. All right, so we've got in our fraction 1 spot, so in fraction 1's spot, we have x plus 2 over x plus 2x minus 2 equals, in our second fraction spot, we have a 3x minus 6 over x plus 2x minus 2. And our third fraction didn't change, so minus 6x over x plus 2x minus 2. And we can combine our like terms here. So we're going to be able to say 3x minus 6x, and that's going to give us a negative 3x minus 6 over x plus 2, x minus 2. Over here we still have our x plus 2 over x plus 2, x minus 2. And we can factor the numerator. So we have x plus 2 over x plus 2x minus 2 equals negative 3 times x plus 2 over x plus 2, x minus 2. And remember, we're trying to solve for x. So now that our denominators are all the same, what we can do to make this easier is, because the denominators are the same, we can actually just cancel them out. Because we have that equal sign there. Okay, so it's all about that equal sign, and that our denominators match. We can cross those out, leaving us with an x plus 2 equals negative 3. Well, actually, it might even be easier to not have done it right there. So if we hadn't done this, and we crossed off our denominators here, that would leave us with an x plus 2 equals negative 3x minus 6. So that's actually going to end up being less work. We're going to add 4x to both sides. And 5x plus 2 equals negative 6. Subtract 2 from both sides. 5x equals negative 8. Divide by 5. So we get x equals negative 8 over 5. And now we just need to check it to see if it's going to work. All right, so we'll go ahead and we'll do our check. We'll do it up here where we've got some room. So we're going to do our check. So 1 over x minus 2 equals 3 over x plus 2 minus 6 times x over x squared minus 4. And so we're going to take that negative 8 over 5 and plug it in. To all of our x spots. And then we're going to work out the stuff on the left. And we're going to work out everything on the right. And we're going to see if they match. Let me just stop us before we get very far. So right here, I moved over a 4x instead of a 3x. That was a crazy thing to do. So let's just rewind really fast. Take out all of our x's because those are not right. Let's go back. Just really quick. I promise it'll be fast. So we should have actually added 3x, not 4x. That's going to give us a 4x plus 2 equals negative 6. Then subtract the 2. So 4x equals negative 8. Divide by 4. And x equals negative 2. So the negative 2 is actually what we're going to be plugging in. There we go. Now our math is correct. Or I should say my math is correct, right? All right, so on the left-hand side, we end up getting 1 over 4. And on the right-hand side, we end up getting an error because we have a 0 in the denominator, which you can't have. Remember that when we cross these out here, that means that x was not allowed to equal 2 or negative 2 because it's going to give us the zeros, right? So this answer right here, even though we got an answer, it won't work. So this is going to be no solution. And this is an extraneous answer. Because we got it, but it doesn't work. So no solution.